Hi, if you're watching this video, you're watching the first lesson in linear relations. In this unit, we'll be talking about how math can be used to draw graphs and lines. Now, this unit may at first sound a little easy, but it's actually quite challenging. So please watch this video at your own pace and take in what you need to know, because this unit will appear again in grade 9, 10, 11, and all the way through grade 12 and university. So take your time, pay attention, and we'll begin. So, what does the word linear mean? We're going to start off really easy. The word linear means straight or straight line. So this unit will focus on patterns and graphs that follow straight lines. We'll be looking at math that predicts patterns that follow a straight line. And so the importance of this unit is the fact that we can use mathematics to predict the future if they follow a specific pattern. So, a linear relation is a pattern when put on a graph makes a straight line. So, if you draw the pattern, you will create a straight line. That's why it's called a linear straight line relationship or relation. For example, we have baseballs and the cost of baseballs the cost of each baseball basically. So we have one baseball here and the cost is $3. So I'll draw a dot right there. Now we have two baseballs for $6. We go 2 all the way up to 6. 3 to 9, so we go 3 all the way up to 9. Right? And then 4, we go all the way up to 12. So if I were to draw a line connecting these dots, now, actually, you know what? Let's do this instead. If I were to create a line connecting these dots, you would see that it follows a straight line. So we can say that this is a linear relation, right? If the table on this graph were to give me dots that look like this, I'll use red. Like that. Well, if I were to draw the lines connecting, well, it bent. It's not linear. It's not a straight line. So that is not a linear relation. Once again, a linear relation is when you put the data on a graph and you create a straight line. So how do I know that my x values and my y values? So on a data table, the information that is about time or on a different event are your x values. So in this case, this is referring to days, so day 1, 3, 5, 7, and 9, right? Even though they're not going up by ones, you know it's a change in time. So this will be my x value. My x values will be here. The information that you are recording, the results you get, are your y values. So in this table, we're measuring the height of something, whatever it is, over a period of days. So your x value are your days, and you're measuring the height. These are your results. So that's your y value. Typically on a table, your x value is on your left, your y value is on your right. Okay? So if it's recording to different, so if I made a table on number of people who like different sports, and I made a table that said hockey, soccer, racquetball, tennis, those different categories would be my x values, while my measurements, the number of people who like those sports, would be my y value. That would be another example. So how would I graph this data? So on your own, just take a look on the computer screen. You don't have to draw anything or do anything specifically if you're watching this, but just picture, how would you graph this data? What would be my x values? What will be my y values? So just take a minute to take a look at this and see how you would do it. Okay, hopefully you paused the video. I'm going to start drawing the dots. So day 1, now we've established a change in time, or over a period of time, or change in categories is your x value. So day 1, this would be my days, right? Days would be here, right? And height, I'm just going to put h for height because I don't have room. Okay, so day 1, we had 0. So I draw a dot at 0. Day 3, so I skip 2 because I don't have data for 2, so I go to 3, and I go all the way up to 4. Okay, 5. Okay, so I skip 4, and now I'm on 5, and I go all the way up to 8. 7, so I skip 6, and I go all the way up to 12. And then 9, go all the way up to 16, so 9 all the way up to 16, so it should be like roughly right here. A little bit off the charts, but roughly right there. Okay, so is this data linear? Well, hopefully I drew the dots correctly, but yeah, there you go. It should be linear. Even though the x values aren't going up by 1, the connection between the dots go through the same sections. They go through a straight line. They follow a pattern that makes a straight line. And so you could say this data is linear. Right? You can see that straight line when you put that data on the thing. So you can say it's a linear relationship. So making data tables. What would the data table look like for this? Right? So if I had this graph and I said, okay, make the data table. Make the table. So in this case, we had the table, the data table here, and we made the graph. In this case, we have the table. We have the graph, and we want to make the table. Okay. So I'm going to see if I can insert a table here. There you go. Okay. And I'll just have, so we have 2 different categories, so 2 columns, and 1, 2, 3, 4, 5, 6 different rows. I'm just going to add 7 for the titles. Okay. So what would my table look like? So when I'm typing here, I'm going to say, okay, this one's going to be my x value, because typically your x value is on your left. I'm going to say temperature. On this side, I'm going to say volume. All right, so temperatures are my x values. The information I have data for is 20 here, 40 there, 60 there, 80 there, 100, and 120, right? This is the information that I have data for. You can see it. I don't have data for 30. I don't have data for 50. I'm not going to put it in. Okay? And then I'm going to have the measurement of my volumes. Well, I have information on 20, right? If at 20 degrees, the volume's 60. So I put 60. At 40, it's at 65. At 60, it's at 70. And you can already sort of see a pattern going on, right? You can just keep going. A situation like that where you can start seeing that pattern, right then and there is a big hint that that's probably a linear relationship. Because you can predict that pattern. So that's what the table would look like. Right? So, ordered pairs. So this is a review of graphing because a lot of times students make mistakes when they say, give me the ordered pair. An ordered pair is a point on the graph given by x, bracket x and y, right? So you have to write it like this. It's bracket, whatever the x value is, comma, whatever the y value is, closed. For example, x is 20 and y is 60. We know that. X is 20, y is 60, right there. So you can draw that dot or write that dot as an ordered pair by writing this, 20 to 60. And that'll give you the ordered pair for that point on the graph. So if I were to ask you, write an ordered pair, I want you to write the x value and the y value enclosed in brackets. Now you need that comma there, otherwise I would think this was 2060, right? So an ordered pair is the written form of a point on a graph. So make a data table on this chart. Just a quick review for graphing. Make a data table because that's important for linear algebra because you're going to have a hard time finding patterns without a data table. All right, hopefully you pause the video. All right, now make a data table on this chart. Okay, pause the video. All right, I'm going to move on from here. What patterns do you see? When you made your tables, what patterns did you notice? Well, you probably noticed, right? We had this one, so we're doing this one, right? Or is it the same one? Oh yeah, here we go. They match here. So you probably noticed that the y values are going up by 3, right? When you made your data table, we went 1, 2, 3, 4, 5, 6, 7, right? So our x values are here. Our y values went 0, 3, 6, 9, 12, 15, and 18. Our y values kept going up by 3. That's the pattern you'd probably be able to see. As you made the data table, you probably realized that you could start predicting what the next number would be before you even saw the dot. Right? This is what linear algebra lets you do. Now, we all have a relative sense of how to do it because we were able to predict it before we did the math. But when things start to get more complicated, when we start doing bigger equations, linear algebra will help us be able to make those predictions. So, why are being able to read linear patterns important? Linear relations are important for finding patterns and predicting events. Right? Cost of cell phone by number of months. Well, you can see the cost of cell phone starts to go up over a period of time. Right? The cost of a cell phone over a number of months has been increasing linearly. And using this information, knowing how much it's going up by, right? Knowing how much it's going up by, well, we could predict in 12 months, what will it be? Because it follows the same pattern. For this graph, we could predict what 8 would be, right? Or what 7 and 8 would be. Well, at 6, we have 18. Well, at 7, what should it be? Well, we kept going up by 3, right? So 7 should be 21. What should 8 be? Well, we're going up by 3, 24. Even though it's not on the graph, I know that these will be the values if the graph kept on going. I could predict those values. And that's important for real-life information like this, where you could predict, well, what is the cost of a cell phone after 2 years, 3 years, 10 years? And you could actually predict that. So once you know the linear pattern, you can predict how much the numbers will go up or down. Because again, patterns can start to go down as well. The values can start to decrease. And you can predict how much they will decrease by, or predict how much they will increase by. And so it's important to read information this way because it allows us to make predictions. It allows us to interpret information and use it. So, if the y values go up by 3 for every x, what would the value of x be? What would the value of y be if x is 20? So, we went from 0 to 6, right? At 6, we have 18. What would the value be? What would the y value be if x is 20? So, pause the video and figure it out. Okay, hopefully you paused the video. So if x is 20, y should be 60, right? Y should be 60. And that's because, well, at 7, we go up by 3. At 8, we go up by 3, like I showed you here, right, to 24, right? And then at 9, it'll go up by 3. And as you keep following this pattern, at 20, you would hit 60. And you just have to follow that pattern, adding 3 every time until you reached x of 20. Okay, so take a look at this. Now I don't have a data table. I don't have any information other than the chart. What would the 10th ordered pair be? So pause the video and try that. Okay, hopefully you paused it. So, the way you'd solve this is first you would need to find your pattern, right? Well, you can do that by making a data table, and I'm going to make a bad data table, so don't do it the way I did it, but we're going to have our x values, line, our y values, right? At 1, we have 5. So at 1, we have 5. At 2, we have 10. Already, you can probably already figure out that pattern. At 3, what should we have? 15. Or 20. Yeah. At 5, 25, and then at 6, we should have 30. So you already know what the pattern should be. We're going up by 5s. 5, 10, 15, 20, 25, 30. So what should 7 be? Well, that should be 35. 8, 40, right? 9, right? 45. The 10th value should be 50, right? The 10th value should be 50. And so you just follow the pattern. That's it. What would y be if x is 20? So in this case, it's a little different because our x values aren't going up by 1. How would you solve this? Pause the video and try and solve it yourself. All right, hopefully you paused it. So I'm just going to move this chart up a little bit. X value of 20. Okay, so I'm going to draw another bad chart. Don't copy me. All the way across. Y. Okay, so my first x value where I have proper data is technically 0, but I'm just going to skip that because that doesn't help us. I'm going to start at 2. Well, at 2, I have 6. Well, at 4, right? At 4, I have 12. At 6, I have 18. Right? At 8, I have 24. At 10, I have 30. And then at 12, I have 36. So, oops, 36, there you go. So what is the pattern we see? Well, whenever x goes up by 2, right? Whenever this went up by 2, this is going up by 2, right? We know this. Well, this is going up by 6. Okay. Well, if this is going up by 6 every time, then I can just keep going. 14, right? Go up by 6, right? Should be 42, right? 16, right? Go up by 6, 48. 18, I'm probably going to run out of room, right? Go up by 6, right? Ah, sorry, my mouse messed up. 1 second. Okay, let me try that again. Okay, so at green 18, right, we should get 54, right? And then at 20 should be 60. 60. All right, so at 20, at x is 20, our value should be 60. Okay? So that's basically how you predict patterns using these graphs. You just follow this linear pattern. Try these questions as practice. This will help you develop a sense of linear algebra and how to solve them. Right now, it's starting off pretty easy, right? We're just following a pattern. Now we're going to be using more complicated math and solving larger problems. So hopefully this was useful, and I'll see you next lesson.